energy. Energy is necessary for everything we do in our daily lives, from cooking our food to washing our clothes to drying our clothes to getting around and finding our way to or from school or work or the grocery store. And we have a variety of energy sources available to make these activities possible in our daily lives. And we're going to take a look at several of them here now. U.S. energy use by sector, most recent data is available from 2017. And this shows that 32% of U.S. energy is used for industrial purposes, 29% is for transportation, 20% is residential, and 18% is commercial. In 2017, we used 97.7 quadrillion British thermal units of energy. Okay? And most of that went into industrial applications. Residentially, we used a fair amount less than we did industrially. So what are we using the energy for, and where does it come from? Okay. When we look at energy consumption by energy source, 37% of that 97.7 quadrillion British thermal units came from petroleum. 29% came from natural gas, 14% came from coal, nuclear provided 9% of the energy, and renewables provided 11% of the energy. And when we look at renewables, 45% of them came from biomass, which is things like ethanol, biodiesel, wood for burning for heat, okay, biomass waste, the byproduct of pressing olives, for example, can be used to generate energy. Okay, so those are types of biomass. And then we have hydroelectric, wind, solar, and geothermal as some of the other commonly used sources of renewable energy. Geothermal is not technically a renewable energy. Geothermal comes from the heat in the planet's subsurface, and that energy came from the formation of the planet, and it's gradually dissipating over time and cooling off. But there's such a significant amount of heat in that surface area that we don't see it running out in any near future. So it's basically considered kind of a perpetual resource. It's going to exist for such a long period of time that we can classify it here with the renewables, even though it's not really a renewable, because it's not really going to go away either. We can't use it up. At least that we don't think we can use it up. So when we look at consumption by source and compare 2013 to 2017, you'll notice that our petroleum is about the same, 36 to 37. It went up 1% of our energy use. Natural gas went up 2% from 27 to 29. Coal dropped from 19 to 14. Nuclear went from 8 to 9. Renewable went from 10 to 11. And the statistics within the renewables vary. Okay, but there's some reasons why the coal and the natural gas saw the shifts that they saw. Coal has become a little more expensive to collect and process compared to the costs related to renewables, and there's been a shift away from coal in some cases towards natural gas. Even though they're both fossil fuels, natural gas is a cleaner burning fuel, so it produces fewer pollutants when we use it. And there's been a growth in the renewable energies industry because of the decreased cost in the infrastructure for renewables. This was an estimate of where the energy reserves existed globally. It was published in 2013. I kept it in here because I couldn't find a more recent source of it. So the statistics, the amount that's there, aren't accurate, but I kept it in here because the countries who have the energy reserves are the interesting part of this. So if you look at oil, Venezuela, which is a South American country, has the largest reserve of the world's oil supply. Saudi Arabia is second, Canada is third, and then Iran, Kuwait, the United Arab Emirates come in together fairly closely, and then we have Russia, Libya, and the rest of the world. So those countries in the Middle East, many of them belong to OPEC, and that determines and sets the world oil prices. Even though individually they don't have as much oil as some other countries, collectively they have a lot of control over the energy market specifically related to oil. Natural gas, Russia is the top source or reservoir for natural gas. They have far more of it than any other part of the world. And the United States would be the coal. If coal was as valuable as oil, the United States would be the top source for coal globally. We have a lot more coal than we have other energy reserves. So that's the interesting part, is where the energy reserves are at globally compared to other energy reserves globally. So when we look at a barrel of oil, you hear about the cost of oil, you hear about the cost per barrel. We measure how much oil is available in barrels. We measure production in barrels. So you hear about barrels of oil all the time. But what's in a barrel of oil? A barrel of oil is about 42 gallons. And within that barrel of oil, we can make 19 gallons of gasoline, 12 gallons of diesel, 5.43 gallons of other petrochemical products like tar, asphalt, etc., and then 3.82 gallons of jet fuel for flying airplanes, and 1.75 gallons of oil, heating oil for oil furnaces in your homes and businesses. What do we use the oil for? Uses for oil, common petroleum products, your gasoline, diesel fuel. Those are what we think of, but also heating oil, propane, jet fuel, liquefied petroleum gas, paraffin wax, kerosene, butane fuel, that's what that can is, asphalt roads, petroleum coke, which is used in the manufacturing process for other goods and products. These things are some of our uses for oil. But beyond that, we also use petroleum to make a number of things that we use every day: our electronics, clothes, contact lenses, skis, glue, insulation, AstroTurf, candles, dentures, plastics, including toys, petroleum jelly, crayons, antifreeze, upholsteries, fabrics for our furniture and our carpets, roofing materials, shower curtains, ink, solvents, vitamin capsules, so cosmetics, trash bags, cleaning products. All of these things get made using derivatives from petroleum products. Do all examples of clothing get made from petroleum products? No. Cotton is a natural fiber, but your synthetics like rayon and polyester, your polar fleece sweatshirts, these are materials that are made out of petroleum-based products. So even if we're going to end our dependency on fossil fuels or oil for transportation, we'd have to replace oil or petroleum in all of these other products in order to completely get rid of our use of petroleum. Fertilizers, lubricants for engines, tires, heart valves, soaps, these are all things you don't think about, but they come from some of the products that are made from petroleum or use petroleum in their process. Okay, so you oftentimes also hear, so biggest thing we think about though when we think about petroleum is our gas, the fuel for our vehicles. And you hear people grumble that, oh, gas is so expensive, I wish it would get cheaper. When I was in college, I remember paying less than $1 a gallon for gasoline. I think even got down into the 80-cent range once during a gas war. Most of you have probably never even heard of a gas war. They don't happen very often anymore. But gas prices got really low for a while when I was in college. And they were, around $1, $1.50 most of my life until about early to mid 2000s. And then gas prices started going up, and at one point they were close to $4 a gallon, but they've come back down, and now they've been under $3, around 225 to 250 for probably a lot of your driving years. But when you look at our gas price and compare it globally, you'll see that our gas price is actually not that bad. This is 2018 statistics, adjusted for the U.S. currency, and price per gallon. So in the United States in 2018, the average price per gallon was $2.60 per gallon. But when you look at Norway, it was $6.89 a gallon. Italy was $6.60 a gallon. Sweden was $6.12 a gallon. Germany was $5.95. So the UK was $5.83. Most of Europe was somewhere between, close to $6 or between close to $6 and close to $7. You see dropping below that in Japan, South Korea, it's about $4.85, $4.70. In Mexico, China, South America, India, it's around $4 a gallon, and then the U.S. drops to $2.60. Russia's $2.48, and Saudi Arabia is $2.06. Iran is 54 cents a gallon. Saudi Arabia and Iran, because they have so much petroleum, their gas doesn't have to. They drill for it and process it close to home, so there's less transportation costs involved and their fuel is less expensive. But we're some of the least expensive gasoline in the world. When you take those two out, because of their abundance of oil, they have much, and the proximity to the production and distribution is so close, it's much, much less expensive. We're way cheaper gasoline price-wise than most of the rest of the world. So where does your gas money go? When you buy a gallon of gas, there are different parts of that money goes to different parts of the process. So this is a comparison. It shows you 2009 to 2018, the average retail price in that period of time, and then it shows you specifically the 2018 average retail price. So in 2018, the average retail price was $2.72 a gallon. 56% of that $2.72 went into the cost of the crude oil. Okay? Finding it, drilling for it, transporting it. Okay? 17% went to federal and state taxes, 13% went to refining it. So you got it out of the ground and you moved it to the refinery. Once it's there, then you have to process it and make it into gasoline, and then you have to distribute it and get it to your gas station and market that gas station or market the gasoline brand. So about 13% goes into both the distribution and marketing, 13% goes into the refining costs and profits. Okay? So then you'll notice here from 2009 to 2018 that 60% of the cost of a $2 gas was $2.88 per gallon as on an average from 2009 to 2018. And then 60% of that 288 went into crude oil exploration and drilling and getting it out of the ground. And that's because the cost per barrel of oil was higher in that period of time. In 2018, it was lower. When the cost per barrel of oil goes up, then the percent of your fuel price going to crude oil production goes up as well. Which brings us to, and by the way, the gasoline is used for all those, or petroleum is used for all those things outside of gas. But gasoline and diesel are our primary uses of the petroleum. The single largest use is for transportation. Other fuels provide us with things beyond transportation. Coal in the past was used, when we had coal-powered boilers, steamships and trains ran on coal. Today they run on other power sources, particularly diesel fuel, but coal today still has a very large role to play in our energy needs. Okay? We use it for electricity, steel production, and cooking and heating. There are still places in the world where you actually burn coal as your heating source, and it is also as a source for your kitchen stove as a cooking source. In the U.S., our coal is located in these areas that are purple. You'll notice that in North Dakota and Montana, there's a large amount of coal out here. Also in these areas in North Dakota and Montana, you'll also find oil. So we actually have oil, natural gas, and coal in North Dakota, although we have definitely way more coal than the other two. When we look at U.S. energy sources for electricity, as of 2016, you'll notice that coal makes up one of the largest percents of our electricity generation. This has shifted. When I started teaching environmental science, 50% of our electricity in the United States was generated from coal, and now only about 31% was, as in 2016, whereas 34% was in natural gas. And like I said earlier, part of that is happening because natural gas is a cleaner burning fuel, and so there's been a shift away from coal and a little bit more towards natural gas. 20% of our electricity comes from nuclear power and 15% comes from renewables, with hydropower being 6.6% of our renewables, or the largest single amount of our renewables. Wind being 5.7%. Biomass being 1.5%, solar being 0.9%, and geothermal being 0.4%. There are changes coming in with this. This was a 2016 statistic, but in April of 2019, renewables surpassed coal for electricity generation for the first. So the renewables surpassed coal for the first time in April of 2019. And you'll notice that In the early 2000s, our coal production was really relatively high. This is 180 million megawatt hours of electricity. That's what this line right here is at. And it stayed roughly between 140 and 180 from 2005 through about 2009. And then it dropped a little bit, and then it went up, and it dropped quite a bit, and then it went up, and it's been up and down, but overall trending downward until this year. And while renewables, on the other hand, have gone up and down, but trending upward. And in 2019, for the first time ever, you'll notice that the renewables are actually generating more electricity than the coal. So when you go back here, where this slide showed you that coal was 30% of our electricity generation and renewables were only 15%, in 2016, the next time this graphic is produced, that will should show that the renewables have a much larger percentage of the pie and coals has gotten smaller. Okay. So what does all that electricity look like? Well, this is the United States. This is an aerial satellite photograph taken time-lapse stitched together, because obviously it's not necessarily night. In the US, it could be night all across the country at one time, but the satellite's not going to be able to get a picture of the entire U.S. at one time. So it takes, as it travels across the country, it takes pictures and then they stitch them together, and then you get this map. And you can see on this map, this is the U.S. at night pre-Bakken, which I'll explain in a minute. But this is the U.S. at night, and you'll see that every major city in the U.S. shows up on this map. The larger the city, the brighter the blob. There's more electricity and there's more heat, and the satellites pick up on both of those things. And so you can see here, this is BOWASH, Boston to Washington. It's almost one continuous city here. And then you can see here's Chicago, here's Minneapolis, St. Paul, here's Fargo, North Dakota, Valley City, Jamestown, Bismarck, Dickinson, Billings, Missoula. You can drive right along the interstate by following the light blobs. Even little old Wahpeton, North Dakota is right there. You can see us from space. Okay. So what did I mean by about the Bakken? So the Bakken is the oil shale formation in western North Dakota that experienced an increase in production in the last 20 years. And this is what the night sky looked like out there before that increase in production. And then this is the U.S. at night post-Bakken. So once the increased oil production happened in the Bakken Shale Formation, you can see there's a lot more, looks like light pollution. It's not just light. There is the reason that you see this is twofold, both connected to the same thing. When you drill for oil, typically you're also going to find natural gas. And the natural gas, there's no pipelines, there's no infrastructure to move it away from where the oil rigs are at. So a lot of times it gets burnt off. It's called flaring. So you've got the light from the flares, but you also have the heat from the flares. And remember I said that these images are generated, they pick up on the light and the heat. So a lot of this has got more to do with the heat from the flares than the actual light from the flares. But you can see that it made western North Dakota and eastern Montana show up a lot better on the map. What about globally? When we look at this map globally, this is just showing you the Bakken takes this piece of the map out and blows it up. So you can see that the light, this is scattered. It's not complete, there's gaps in between these little gold dots, whereas this is more solid. But you can see this area where this heat and light is at is bigger than Minneapolis and bigger than even maybe the Chicago area. So it was a significant environmental change that happened out in western North Dakota with the increase in oil production. Okay. Worldwide, when we look at this, the global light pollution is, you can see that most of Africa is dark. It doesn't have a huge amount of lights going on. Where you do have a lot of electricity and is where you have a lot of people here. South Africa is along the Mediterranean Sea up here, where your people are more concentrated. Here's the coast. Coastal areas, you have more light than you do inland. Okay? The same thing with Australia. You have a lot more light on the coastal areas and far less inland. Japan, you can find it very easily. It's this nice big ribbon right here. Most of Europe's lit up really well. Most of the United States is lit up really well. Canada is fairly dark through a lot of it because it's very rural areas. There's not as many people here as there are in southern Canada. This light area here, this is not the United States. This is southern Canada. This is southern Canada. So you have where you don't have large populations, you don't have this light pollution. Why do we call it light pollution? Because if you've ever tried to, if you go outside on a night that's not cloudy and look up at the sky, count the stars. Okay, yeah, I know this seems like an insurmountable task, but try. Go outside and count the stars. Then drive out of town. How far out of town do you have to get before you can't see the lights from the town on the horizon? If you live in a flat area like North Dakota, like eastern North Dakota, you have to drive quite a distance before you can't see the light haze from the town that's close to you. I grew up 15 miles north of one of the biggest cities in my area, and I could see the lights of that town glowing on my farm because there was just that many people and that much light concentrated in one area. And then when that light goes up into the sky, it also causes what we call light pollution, which makes it harder to see the stars. If you ever get to be somewhere where it's really dark, where it's a long way to an urban area, you look up at night and you get to see lots of stars because they're not blending into the light background. The light pollution from the city was causing them to blend into the background and you don't see them as much. You only get to see the brightest stars in urban areas because there's so much competing light from street lights and homes and businesses. Go by a car dealership at night. It's lit up like a Roman candle, so anti-theft and security reasons, but that's putting a lot of light up into the atmosphere. To counter this, a lot of times when you see newer light infrastructure, instead of having lights that go upward, the lights are actually pointing downwards. You still get the light for safety and security reasons, but you're not sending as much light up into the atmosphere. Okay. So since coal is a primary purpose that we use it for is electricity, if we were to look at your electrical use and attach it to coal, how much do you use in a year? Okay. If your family uses an electric stove, then each year you use about 500 pounds of coal to power that stove. If you have an electric water heater, you use another 4,000 pounds of coal to generate the electricity to power the water heater to heat the water for your bathing and washing dishes and cleaning. And if you have a refrigerator, you have another 500 pounds of coal. Now that's just your stove, your water heater, and your refrigerator. That doesn't get into your washing machine, your dryer, your power for your TV and your computer and your cell phone. Those are just 3 major appliances in your home. Okay? Just food for thought. Okay? Burning coal has some consequences. One, it forms mostly carbon dioxide and water when it's burnt for energy, which CO2 and water are the primary things that are released because coal is mostly a hydrocarbon, and that's hydrocarbon. It's carbon. It's a big long chain of carbons with hydrogen and oxygen attached to them, and when you burn the coal, then you break those chains and it produces byproducts of carbon dioxide and water. But there are also impurities within the coal, and when you burn the coal, you release those impurities into the atmosphere, particularly sulfur dioxide, which creates acid rain and haze, nitrous oxides, which create acid rain and smog, mercury, a highly toxic heavy metal, and particulate matter like soot, which can cause respiratory ailments. Now, we've gotten better at capturing these things in the process of power generation so they don't go up into the atmosphere as much, but we don't capture all of them, so they still do go up into the atmosphere, especially if you're using older technology when you're burning your coal for power generation, which is more common in developing countries than in developed countries. Which brings us to natural gas. Natural gas is used for things like electricity, cooking, heating. We also use it for transportation. There are vehicles that are powered using natural gas. Natural gas is a much cleaner burning fuel. It produces, it has fewer impurities in it when you burn it. It's like coal. It's going to produce carbon dioxide and water vapor. but it's not going to have as many impurities that go up into the atmosphere. Natural gas, many furnaces run off natural gas. There are people whose kitchen stoves run off natural gas. People they have natural gas dryers, natural gas water heaters. And those are typically the three appliances in your home that you might run off of natural gas, with the stove being the most common of the three.